This lesson, we're going to learn how to use dot product to find the angle between two vectors or to see whether or not two vectors are perpendicular to each other. The dot product of two vectors u and v is defined by the magnitude of the vector u times by the magnitude of the vector v times by cosine theta, where theta is the angle between the two vectors u and v. Example 1. Given the geometric vectors, we are going to find the dot product of the following cases. Part A. First, we write down the formula for dot product. Second, we substitute the values that we know, and we know cosine 60 is a half, then we get a dot product of 42. Part B. First, we write down the dot product again. Second, we substitute the values that we know, and we know cosine 5 pi over 6, which is equivalent to cosine 150 degrees, which is negative square root 3 over 2. Then we get a dot product of negative 30 root 3. Part C, once again, first, we write down the formula for the dot product. Second, we substitute the value in, and we know cosine 90 degrees is actually 0, and anything times by 0 will be a 0. As you can see, all the dot product will end As you can see from example 1, all the dot product will end up with a number, which is just a constant. Therefore, dot product is also known as a scalar product because the result will be a constant, which is a scalar. In addition, when the angle is between 0 and 90 degrees, which is acute angle, cosine ratio is always positive. That means when we know the dot product is positive, we know the angle between the two vectors is acute angle. Next, when the angle becomes obtuse angle, which is between 90 and 180, cosine ratio will be a negative. So we know when dot product is negative, we know the angle between the two vectors is an obtuse angle. Now, the most important one, when the angle is actually 90 degrees, cosine 90 degrees becomes a 0. That means when dot product becomes 0, we know the angle between those two vectors must be 90 degrees. Now, let's look at the algebraic vectors. Given two algebraic vectors, how do we find the dot product? The dot product can be found by the product of the x-coordinate plus the product of the y-coordinate plus the product of the z-coordinates. Now, let's look at example 2. For part A, given two vectors in two dimensions, we want to find the dot product between u and v. So first, we are going to multiply the x-coordinates plus the product of the y-coordinates, which is negative 15 plus 8, which is negative 7. Part B, given two vectors in three-dimensional space, we want to find the dot product. First, we multiply the x, and we multiply the y, and we multiply the z. We add them up, and we're going to have negative 2 plus 0 plus 32, which is 30. Example 3. Given the magnitude of the vector A is square root of 5, we want to find out what will be the value of vector 8 dot vector A. So first, we write down 8 dot A, and using the dot product formula, we get magnitude of A times by magnitude of A times by cosine theta. So let's draw two vector A's together. If I want to find the angle between those two vector A, I bring the tail of the second vector to the tail of the first vector. You will see they overlap. That means the angle between them will be 0 degrees. So which means this will be magnitude of A times by magnitude of A times by cosine 0 degree. And we know cosine 0 degree is actually 1. So 8 dot A means magnitude of A square. So if the magnitude is root 5, then we're going to have root 5 squared, which is going to be a 5. Therefore, we know vector u dot vector u equals to magnitude of u squared. Next, we're going to learn how to use dot product to determine the angle between two vectors, either in 2 dimensions or 3 dimensions. Part A. First, let's write down the dot product formula. Second, because vector u and vector v given are algebraic vectors, so we multiply the x plus we multiply the y equals to, let's find the magnitude of the vector u, we'll do square root of x squared plus y squared, same thing for magnitude of the vector v times by cosine theta. Third, we're going to simplify it to be negative 21 equals to square root of 61 times by square root of 10 times by cosine theta. Since we want to find theta, so we have to isolate for cosine theta. We divide it by square root of 61 and square root of 10 on both sides. Now we're going to have this. Then we're going to take the cos inverse to find the theta. So theta is approximately 148.24 degrees. Now let's use the graphing device to graph them. As you can see clearly, the angle between vector u and vector v is approximately 148 degrees. Similarly, for part B, first, we write down the dot product. Second, we multiply the x and y and z values, and we add them all up, and we are going to find the magnitude of the vector u. So this time, because it's a three-dimensional vector, so we're going to do square root of x squared plus y squared plus z squared. Same thing for the magnitude of the vector v, and times by cosine theta. And we can simplify to 30 equals to square root of 17 and square root of 93 cosine theta. By isolating for cosine theta and taking the inverse of the cosine, we are going to get theta is approximately 41.02 degrees. For the three-dimensional vectors, we use the GeoGebra to graph them. So this is the positive x, positive y, positive z axis. As you can see, the angle between those two vectors is approximately 41.02 degrees. One of the very important use of the dot product is to see whether or not those two vectors are perpendicular. If so, then the dot product will be 0. Example 5. For what values k are the vectors a and b perpendicular? So if vector a and vector b are perpendicular, that means the dot product between them will be 0. Since they are algebraic vectors, so we find the product of the x and y and z coordinates, we add them up, it should be 0. Then we isolate for k, you will get 3k equals negative 5, so k will be negative 5 over 3. Example 6. For what values of m are the vectors u and v perpendicular? If they are perpendicular, means the dot product will be 0. Once again, we multiply the x, multiply the y, multiply the z, add them all up, it should be 0. But this time, we will have a quadratic relation. That means we have to use either the quadratic formula or factoring to solve for m. And we got m minus 6 times by m plus 3 equals 0. That means m minus 6 will be 0, which means m equals 6. And m plus 3 will be 0, means m will be negative 3. Therefore, you have two possible values for m. Example 7. If the vectors a plus 3b and 4a minus b are perpendicular, and magnitude of a is 2 times magnitude of b, determine the angle between those two vectors, a and b. First, we know those two vectors are perpendicular. That means we know a plus 3b dot 4a minus b will be 0. Then, we're going to use the distributive property to expand the dot product. So we will have a dot 4a. So 1 times by 4 will become 4 and 8 dot a. Next one. 1 times by negative 1 will become negative 1 and 8 dot b. Next one, 3 times by 4 will become 12 and b dot a. And positive 3 times by negative 1 will become negative 3 b dot b equals 0. In order to simplify this, we need to know whether or not there's a difference between a dot b and b dot a. So let's write down the dot product for a dot b and b dot a. As you can see, this is all multiplication. That means the product will be the same. That means a dot b is b dot a. At the same time, we know a dot a is magnitude of a squared and b dot b is magnitude of b squared. Now, let's simplify this equation here. We are going to have 4 magnitude of a squared, negative 1 plus 12 is going to be 11, 8 dot b minus 3 magnitude of b squared equals 0. Since we see another dot product here, So we're going to use the dot product formula again to simplify this equation. Now we try to eliminate the many different variables. So let's use the question again. We know magnitude of the vector A is 2 times by magnitude of the vector B. So every single magnitude of A here, we're going to replace them. After that, we are going to try to isolate cosine theta because that's the angle between vector A and B. So 16 minus 3 will be 13. Move then to the other side of the equation. We're going to have 22 magnitude B squared cosine theta equals to negative 13 magnitude of B squared. And divided by 22 magnitude B squared on both sides, we can isolate our cosine theta. Then we just need to do a cos inverse to find theta, which is approximately 126 degrees. Therefore, we know the angle between vector A and vector B is approximately 126 degrees. Example A. Given the magnitude of A plus B equals the magnitude of A minus B, we want to prove the non-zero vectors A and B are perpendicular. First, let's write down the given information. Next, we're going to square both sides. The reason is, we know the magnitude of u squared really means the dot product of the vector u by itself. So, I can write as vector A plus vector B dot vector A plus vector B equals to vector A minus vector B dot vector A minus vector B. Using distributive property to expand the dot product, we're going to end up with this line here. And we know A dot B and B dot A are the same. So we are going to simplify to 2A dot B and minus 2A dot B. And we know we can subtract magnitude of A squared on both sides and magnitude of B squared on both sides. Then we're going to end up with 2A dot B equals negative 2A dot B. That's add 2A dot B on both sides. We're going to have 4A dot B equals 0. That's divided by 4 on both sides now. We get A dot B equals 0. Since the dot product between the two vectors is 0, therefore, we say vector A and vector B are perpendicular. Example 9. A parallelogram has its side determined by vector A and vector B. Determine the angle between the diagonals of the parallelogram formed by those vectors. In order to have a better understanding of this question, it is always easier to have a diagram to visualize the problem. So first, let's draw a parallelogram and with two straight lines for the diagonals. Then, we are going to label diagonal 1 and diagonal 2 as two vectors to help us to find the angle between them. Method 1. We're going to use vector addition to find those two diagonal vectors. So diagonal 1 is going to be vector A plus vector B, which is going to be 5, 4. And vector diagonal 2 is going to be negative B plus vector A, which is going to be 7 and negative 2. Let's look at the diagram again. The angle at the intersection of the diagonals will be the angle between the two diagonal vectors, because if you move the tail of the diagonal 2 to the intersection point and move the tail of the diagonal 1 at the intersection point, you will see the angle between those two tails will be the angle of the intersection of the diagonals. So let's use dot product between those two vectors to find the angle between them. So we do the dot product, we find the magnitude of each vectors, and we're going to isolate for cosine theta and take the cos inverse. We're going to get theta is approximately 54.61 degrees. Now, once again, because there are two different intersection angles, so if you ever find an angle that is more than 90 degrees, then just subtract from 180 to find acute angle. We always want to find the acute angle at the point of intersection between the diagonals. Method 2. we're going to use equal vectors to help us to find the two diagonal vectors. So first, we have to label the point D, X, and Y. And since those two vectors are both position vectors, that means the tail will be at the origin, the head will be at location 6 and 1, and -1 and 3. So we can label point A is 6 and 1, and point B will be -1 and 3. Now, using equal vectors, we know vector OB equals to vector AD. Then that means -1 and 3 equals OD minus OA, which means we can find point D at 5, 4. Therefore, the vector diagonal 1 is going to be vector OD, which is going to be 5, 4, and diagonal 2 vector is going to be vector BA, which is going to be 7 and -2. Therefore, the angle between the diagonals is approximately 56.61 degrees. And remember, always use the smaller angle, which is the acute angle at the intersection. Example 10. Find a vector that is perpendicular to each of the vectors A and B. So first, we're going to let vector U be X, Y, Z, and vector U is the vector that is perpendicular to both A and B. So we can write vector U dot vector A must be 0, and vector U dot vector B must be 0 because they are perpendicular. Since they are algebraic vectors, so we do X times by 1 plus Y times by 5 plus Z times by -1 equals 0 for the first equation. For the second one, we will do X times by -3 plus Y times by 1 plus Z times by 2 equals 0 for the second equation. However, now we have 3 variables, but only have 2 equations. And we know if we only have 2 equations, we only can solve for 2 variables. So we let Z equals to T, and where T can be any real number. Let's transform our equations. So we have X plus 5Y equals to Z, which means X plus 5Y equals to T, and -3X plus Y equals to -2Z, which is -2T. Then we can use elimination to solve for X and Y. By using elimination, that means one of the variable needs to have the same coefficient. Either X, they both have a 3, or Y, they both have a 5. So here, I'm going to decide to have X to become a 3. So we say equation 1 times by 3, I will get 3X plus 15Y equals to 3T. Then we're going to add those two equations up to eliminate the X. So we say equation 3 plus equation 2 will become 16Y equals 1T. Then we can isolate for Y. It's going to be 1 over 16T. Once we know the value for Y, we can solve for X by using substitution. So let's substitute Y equals 1 over 16T into equation 1. By isolating for X, you're going to get X is 1 over 16T. Therefore, vector U is 11 over 16T, 1 over 16T, and T. So if T equals 16, then our vector U will become 11, 1, and 16. Which is a vector that is perpendicular to both vectors A and B. Let's do a summary of the dot product. Given the formula of the dot product, we need to know theta is the angle between the two vectors U and V. And if the angle is acute angle, dot product will be positive. If the angle is obtuse angle, we know the dot product will be negative. If the angle is 90 degrees, we know the dot product will be 0. And when we do dot product of a vector itself, it's always the magnitude square.